This content is brought to you by Mazunder Academy.
Hello everyone. In this session we will see what is variable, what are the different data types in R, and what are the different data structures in R. So we will look for basic data types in R, basic data structure in R, creating a vector, vector slicing, operations on vector, and at the end there will be some exercise questions or activity. So let us start with the variable. So what is a variable? The simplest definition is it is a reserved memory location to store some values. For example, x equal to 5. So x is the variable, 5 is the value. Next, basic data types in R. So R have the following data types: character, integer, double, complex, and logical data types. We will see one by one all of these. So character data type, what it means: if you store some string or the character values inside double quotes in a variable, then that variable will behave like a character. For example, here hello is stored in x1. So x1 is a character variable. So we can see if we apply type of x1, and if you run this too, then you can see hello is stored in x1 and its type is character. Next we'll see integer data type. So with any number, say for example 5, we know 5 is an integer type, but to make R to understand we want 5 to store as an integer, we will supply capital L with 5, and it will store 5 without L in the variable x2 with the understanding that 5 is an integer. So this variable x2 will behave like an integer. We can see, so type of x2, if we run, then you can see it is an integer type. So 5 is stored in x2 and it will be of integer type. Next, the double data type. So for example, if I store just 5 without L, then 5 will be stored in the variable x3, and the variable x3 will be a double data type. So let me see. It will be double data type, you can see. Next, complex data type. When any data of the form a plus bi is stored in a variable, then that variable will be a complex data type variable. We can see type of x4. If we run, we will see it is of complex type. Then the last one is logical data types. If we store any logical values like true or false in a variable, then that variable will be a logical data type variable. If we see x5, its type, and if we run it, it will be a logical data type. So these are the basic data types in R. Next we will go to the basic data structure in R. So R have the following data structure: vector, list, matrix, data frame, vectors, and arrays. So let's start with the vector. What is a vector? A vector is a sequence of data element having same atomic or basic data type. Now this is the syntax of creating a vector, name of the vector, then C is the concatenation function, then element 1, element 2, element 3, whatever the element you can pass here as an argument separated by comma. So let's go for example how to create vector. So v1 is the name of the vector, C is the function, and 4L, that means I want to store 4 as an integer, 6L, 8L, 10L minus 3L. That means all data I supplied as an integer data, so my vector will be an integer vector. So if I see how it will work, so you can see print v1. v1 is the vector 4, 6, 8, 10 and minus 3, and type of the vector is integer. Next, let us see in v2 we are creating a vector with elements 4L, 6.85. So 4L is the integer and 6.85 is the double data type data. So in that case, what will happen? The integer one will be converted to double. So these both will be stored as a double data and stored in v2. So v2 will behave like a double data type vector. So we can run and check it. You can see 4 was stored as 4.00 because for the second double data type there are 2 decimal places, so it will be converted this data also 2 decimal place 4.00. So 4.00 is a double data type. Next, if we mix some integers, some double, some character, then everything will be considered as character. So you can see here v3 will be created with a mixed data type variable, and you can see 4, 6, 8.45, 10 and high, these all are string, or you can say character, because they are stored within double quotes, and the type of this vector v3 is character type. So this is the different way how, based on the data type of the data, the type of the vector will change. Next, how can you create a vector using colon operator? We already have studied it, so it is just a revision. If you run it, you will get the data. Our aim is to study this one. In colon operator, the gap, it will give you 1 from starting till end. But if you have gap not 1, it is something different, say 3, 4 gap between the elements, then how can we do? In that case, sequence function will help us. So what is the syntax for this? SEQ, then from which number, to which number, and by which number, that is the gap. For example, I want to create a sequence from 5 to 100, like 5, 10, 15, 20 up to 100. So how can I do that? Sequence SEQ from 5 comma to 100, and the gap is I equal to 5. Or sometime if you do not give this from, to and by, R will automatically understand that first one is from, second one is to, and third one is by. And then if you print, you can see the desired output. Next, we will study vector slicing. Slicing is very important sometime for manipulation. We have to work with some part of the data, not all the data. So based on some condition, we have to filter our data, and then the filtered result, on that we will work as per our requirement. So one way is slicing. Let us see. To see the third element of a vector, for example v9 we have created just now, so we want to see the third element. So just simply name of the vector and the index. So if you print it, you will get the third element, that is 15. Third element is 15. Then to print to see the first 5 data of the vector v9. If you want to see the first 5 data, so 5, 10, 15, 20 and 25. So simply you pass name of the vector, then starting index and top index. So I want from first index to fifth index. So 1 colon 5. So it will give me the first 5 data. Similarly, if you want from in between, that also possible to do. So for example, I want from 10th to 13th place. So that also possible, just from 10th to 13th. If you want some specific, say for example, to print 10th, 15th and say for example 20th data, what will happen? How can you do? So you can write print v9 and mention the index. All the indices are not serial and not necessary of the same gap, maybe 17th data. Okay, so you have to put them in a vector. Okay, so 10 comma 15 comma 17. In that case, it will display the 10th item, 15th item and 17th item. If any item is not present, then it will give you NA. Let's see the, so all are there. Let me check, say for example 27th item. So hopefully it is not there. Yeah, so it will give me, because in my v9 there is not 27th item. So if an item is not there, then it will give you not applicable NA value. Similarly, we can extract our data from a vector. Next, we are going to see vector alteration. How can we change a vector? Already we have created a vector. We want to change the vector. Say for example, we want to insert some data, we want to delete some data, we want to append some data. So this all we will see. So append is a function that will do all this addition or alteration, change, everything will do by this append function. So how we are doing? Append v9 comma -7 and nothing mentioned. So by default -7 will be append. Append means, all of us know, append means add at the end. So -7 will be added at the end. So if I run, you can see and print v9, so you can see -7 is added at the end. Suppose I want to add this -7 at the beginning, then how can you do? How can I do that? v9 is the vector where I want to append, and -5 is the data what I want to append, and after equal to 0. After equal to 0 means it will append, it will add at the starting. So if you run and check, the -5 is added to the updated v9 at the beginning. Similarly, if I want to add some data or insert some data after some location, then simply you mention after equal to 3. That means after 3 data, in 4th place it will add -6. So you can see, and if you run, so in 4th location -6 is added. Now to delete an item from a vector, so different options are available. One easy option is name of the vector and then minus the index number. For example, V9, from V9 delete fourth index, fourth item, and the resulting vector you store again in V9. This is the meaning of V9 assignment, then V9 minus 4. That means fourth element will be deleted and the resulting vector will be stored again in V9. So if you just run it, you can see. By the way, before that, let me run V9 once, because we have created V9, some alteration we have done. So I want the original V9. So now if I do, let me show you the V9 once. V9. This is the V9, and if I run this V9 now after delete, then what will happen? You see, so minus 4. So minus 4 means this element 20 is deleted. 20 is deleted. So after 15, 25 here, 20 is deleted. Similarly, if you want to delete few specific locations item, then just minus, and within the vector, if you pass the data within a vector, then all the elements of those locations will be deleted. So here 6th and 9th item will be deleted. You can see 6th and 9th item deleted. Sometimes we do not know the index, but we want to delete few items based on some condition. For example, we want to remove any outlier from the data, or we want to delete some of the data which is very negligible or unwanted or not useful for me, like NA values. Because if you have NA values in the data, it will not allow you to do any statistical analysis. Like if you cannot find out mean, median, this kind of things if your data have NA values. So you have to remove them. So how can you delete those? So to make you understand, I have taken an easy example, like V is a vector created with 5, 6, 1 NA value, 5, 10, 7 NA value, and 3. These are the data. Now, to delete all the data less than 5 and all NA values, how can we do? There are different approaches, but one approach is using in operator. If you remember, we have studied in operator in our earlier video. So how we have done it? From V, not V in the vector, where extract V all the items which is less than or equal to 5. So this part will result, I have written the code here, you can see. So first of all, I have to create the vector created, and then second line, if I run, you can see the output of this line. From V, all the items which is less than or equal to 5, it is included, including NA value. So from V, not V in this smaller than 5 value or even NA value, those all you extract. So how can you understand this? What will be the output? First, from V, 6 is the first item. Whether 6 is falling, how can you understand this? So from V, 5 is the first item, and which item is coming in this one? This also 5. So whether 5 is available here? Yes. In this condition, 5 is available? Yes. So 5 will not come in the output. 6. Whether 6 is less than equal to 5, in this condition it is not coming, here also not coming, so 6 will come in the output. Similarly, NA value, it is available here, so NA will not come, 5 will not come, 10 will come, 7 will come. These two will not come. So if you just run that and see the output, 6, 10 and 7. So you can see my data has been cleaned. What are the conditions I have? I should not have any data less than 5 and I should not have any NA value in the data to do some process further. So this is one of the way of cleaning, or you can say delete some unwanted items from the vector. Then some vector operations like concatenation, addition, subtraction, multiplication, division, and these are very simple, very easy. Say for example, V10 is a vector which is created from 1 to 5. V11 is another vector created using the elements 11, 12, 13, 14, 15. So 5 elements in V10 and 5 elements in V11. And V12 is created using the concatenation function C between V10 and V11. So what it will do, it will concatenate the element of V11 with V10. So if you run this all, you can see 1, 2, 3, 4, 5, it was V10, and 11, 12, 13, 14, 15 is your V11. So both concatenated and a new vector V12 is generated. Similarly, if you want to do addition, subtraction, multiplication, all can be done just normal. But remember, it will be the addition will be done by element wise. For example, if you do that, so you can see how V10 first item will be added with V11 first item. So 1 plus 11 will be 12. Then 2 plus 12 will be 14. 3 plus 13 will be 16. Similarly, 4 plus 5 plus 15, 4 plus 14. So like this, your addition will be done. Exactly in similar manner, you will have the subtraction, then multiplication, then division.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.
So that's all in this lecture, and now at the end there are some exercise questions I have added, so you can try and hopefully you will not get any difficulties. And if you find any difficulties, you can contact me